Hello friends, welcome to your only channel Times of Coding. In our series Scala Express today, we will learn about functional classes. Functional class session will help you to understand object-oriented aspects of Scala. In previous session, we have learned how to use currying function and how to define our own control structures. In this session, we will learn about abstraction, inheritance, and composition. Abstraction is our first interest of topic, which I would like to explain now with below example. Here I'm defining one class called abstract class as factory, and then I'm defining one member function in it called raw material. This raw material I'm defining as array string, and when you run this class with Scala created that class called class factory. Since we are defining this class as abstract, so it may have some member function with definition and without definition. But we cannot instantiate any object from abstract class. We always need to inherit this abstract class to some other classes. So if you see here, I'm trying to create one object, but it is giving us compile time error called class factories abstract cannot be instantiated. So moving on, I would like to define one more member function in it called material count. And here we are simply getting the length out of this array. If you observe here, these functions are not having any parameter. And in Scala, we call such functions as parameterless method, which do not have parameters, and we don't need to include even empty parentheses here. If you see this abstract class definition, we might have defined this function as a variable because it is actually holding a value from .length operation. So I'm doing the same here, and now we will see how to extend this factory abstract class. So here I'm defining this factory abstract class, and then I'm defining one Kingfisher factory, which is having parameter called materials, type of array of string in its primary constructor, and then it is extending a factory type. Since we are extending an abstract class, we need to override abstract method here. So now I'm assigning this materials value to raw material. So in Scala, if you extend some class, like here we are doing factory, it's fine. Otherwise, Scala implicitly assumes that this class will be extending a AnyRef. AnyRef is another version of object class which we have seen in Java. So in Scala, it's an AnyRef class which I'm keeping here. And in Java, similarly, we have got java.lang.object class. Just to show you the hierarchy of classes, so parent class of our abstract class will be AnyRef, and then we have got factory class, and this abstract class we are inheriting in Kingfisher factory. So this is a class hierarchy we are following in our example. While inheriting a superclass to subclass, if your superclass members are private members, they will not get inherited. And if they share same name and same parameters, in that case also they will not get inherited. Instead, they will get override. That override we will see when we will discuss polymorphism. But now, as of inheritance, that member also will not get inherited into subclasses. So now I'm defining one object from Kingfisher factory class, and I'm passing array keeping raw material as water, hops, yeast, and then we are having material counts. If you observe this material count function, we have not defined in Kingfisher factory class, but we inherited factory to Kingfisher factory. That's why we are able to access this function. And since Kingfisher factory and factory, they both are compatible to each other, you can define Kingfisher factory object in type of factory, which I will do here. So this variable I'm assigning a type called factory, which is an abstract factory type. And here I'm assigning Kingfisher factory object to this reference member. One more relation is going on here, which is composing Kingfisher factory object known as array. So with the help of array, we are composing an object of Kingfisher factory type. This type of relationship in Scala we called as composition as object-oriented aspect. So far in theory, we have covered abstraction, inheritance, and composition. Now it's time to do some practical. Now we'll create a package called object-oriented aspect. And in this, we will create one Scala worksheet and we'll give name as example. Now the very first example we have seen how to define abstract class, and we will run this abstract class. So now Scala has defined one class called factory. After defining this abstract class, I was trying to create an object. So we will see if we can create it. So now we have got compile time error called class factories abstract cannot be instantiated as expected. Now it's time to add one more method inside this abstract class, which is material count. So here we are having raw material method, which will store value as array of string type. And then we are having material count, which will count the material from this array of string collection. So now we will execute and it's perfectly fine. Though we can define material count as function as well, but it will make sense if we can just assign the value, because once we create some subtype of classes object, this material.count will never going to change. So I'm keeping as val here as immutable. Now it's time to define some subclasses. So I will keep it one class here called Kingfisher Factory. In this I'm passing one array of string as materials, and this will extend factory type. So you see, we are overriding this function because this has not been defined inside this. What if you don't define this function here? This will have a compile time error. And since we are using IntelliJ IDE here, it will give you few options as well to tackle this problem. So now we are choosing implement method, the first option given from IntelliJ. Okay, and that's how we were getting this count. Now for this question mark, we can assign materials, which we are asking while defining object for Kingfisher Factory. So our subclass got completed. Now we will create one object here called KF unit. In this KF unit, we will define Kingfisher Factory type, and as parameter we will pass array of water hopes east, which is required for Kingfisher Factory. So now, yes, our function has been defined. Now after this, I have talked about, will this object have access to material count, because material count we have defined in factory, which is an abstract class, and here we are extending factory. So this Kingfisher Factory object must have access to that material count because it is not final also here. So let's see now. And material count, and yes, it is giving us the value as expected 3. 3 is the number of elements we have passed inside this array, and we are getting the same. Now when we were creating this object, we have seen some hash code with class name. In fact, this function you can also override, which is override def toString. This toString is coming from the any class. So any class is the topmost parent class in Scala that we will discuss in our later session, but you can keep this as Kingfisher Factory object. Now when you run it, you will get Kingfisher Factory object instead of that hash code. Right now we are creating an object out of this Kingfisher Factory, and we are storing in KF unit, and we have already checked factory object cannot get instantiated. Since Kingfisher Factory and factory is compatible type, you can do one thing. You can assign Kingfisher Factory object to factory type of reference member. Now you see there is no compile error, and when we execute, it is completely fine with Scala interpreter as well. With this example, we have covered today's content. I hope you understand today's topic. You can like, subscribe, comment, share with your friends to share knowledge. Thank you. Have a good day.